In this lecture, we'll see how to implement hash tables using open addressing technique. In our hash table, we'll store records of students. So we have made this simple class, student record, which is these two attributes, student ID and student name. We'll use this student ID as the key. And we'll assume that -1 is not a valid student ID. So whenever we have to delete a record from the hash table, we'll just change its student ID to -1. So here we have this constructor, get student ID method, set student ID method, and this str method. Now this is our hash table class. We implement our hash table with the help of this Python list, and we have named it array. This attribute m denotes the size of the list or the hash table, and this attribute n denotes the number of records. In this constructor, we are passing the size of the table. And if the size of the table is not provided while creation of object, then we'll create a table of size 11. This method hash1 implements the simple hash function that we'll use for mapping the keys to array indices. Now let's see this method insert. We have used linear probing here. We have to insert this new record into the table. So first we extract the key from the student record. Now with the help of this hash function, we find the hash value. We take this variable location and initialize it to this hash value. Now we come to this for loop. In this loop, I goes from 1 to m-1. And we are using linear probing. So this is how we calculate the next probe location. We insert the new record at this location if the location is none, or if the student record at this location has student ID -1. After inserting the new record, we increment this variable n, which denotes the number of records, and then we'll return. If we find the key somewhere, then we'll raise this exception. If the control comes here, it means that we have visited the whole table and did not find any empty location. So we'll print this message. Now let's see this method, search. This method will search for this key in the table and will return the record with this key. And if the key is not present, then it will return none. This method is like the insert method that we have just seen, but here we will not stop when we reach a location whose student ID is -1. And we have discussed the reason for this in the previous lecture. We'll stop only when we reach an empty location. If we find the key, then we'll return the associated record. We are using linear probing, so this is how we calculate the next probe location. And if the control comes here, it means that we have visited the whole table and the key was not found, so we return none. Next, we have this method display table that displays the whole table. Now let's see this method delete. This method will delete the record with this key from the table. As we have discussed earlier, to delete a record, we'll just set its student ID to -1. And if this key is not present, then this method will return none. Now let's see this code where we have tested our hash table class. Here we are entering the size of the hash table, and then we are creating this hash table object. Now we have this while loop. Inside this loop, first we display the options and then enter a choice, and then depending on the choice that we have entered, we'll call a particular function. If the option is 1, we are calling this method insert. If option is 2, we are calling this method search. If this method returns none, it means that the key is not present in the table. Otherwise, we'll print the record with that key. In case 3, we are calling this method delete for deleting a record. And in case 4, we are calling this method display table for displaying the table. Now let's run this program. First, we insert some records. Let's display the table now. So this is our table. Now we'll search for a record. So it displayed the record. Now let's search for a record that is not present in the table. So it is displaying that the key is not found in the table. Next, we'll try to delete a record. So this record was deleted from the table. We have used linear probing here. If we want to use quadratic probing, then in all the methods, we have to use I into I instead of I. So here, we'll have I into I instead of this I if we use quadratic probing. Similarly, here also we'll have I into I, and here also we'll have I into I. And if we have to use double hashing, then here we'll use another hash function. Now earlier I told you that if the hash table becomes too dense, then its performance decreases. And in that case, we do rehashing. So now let's see the modified program. So this is the modified program where we have performed rehashing. We have created a new method, insert1. Inside this method, we perform the insertion by calling this method insert. But before that, we check this condition. If the size of the hash table is more than twice the number of records, then we call this method rehash. We'll double the size of the hash table, and we have to keep the size of the table a prime number. So we select the first prime after 2m. And for this, we have used this method next prime. Let's see this method. So this is the method next prime. And inside this method, we have used this method is prime. These two methods are very simple. So now let's see this method rehash. Inside this method, first we allocate a new table with the new size that was sent as argument. Now we insert all the records in this new hash table. And then we change self.array to temp.array and self.temp to new size. This rehashing is an expensive operation. Its running time is order of n. But once it is done, the new hash table will have good performance. We have modified our delete method also a bit. If there are very few entries left after a deletion, then we'll reduce the size of the table to half and rehash all the entries. Now let's run this program. This is our table. We'll insert one more record. So we can see that the rehashing was done and the new table size is now 17. This is our table now. Let's search for a record. Record is displayed. Now let's delete some records. This is the table now. Let's delete one more record. And again, we can see that rehashing was done. Let's display our table. So now the table size is only 11.